Hello everyone, thank you for joining me in my presentation today. My name is Dr. Rouhi Faisal. I'm an assistant professor of management, Management Department, College of Business, Liwa University, United Arab Emirates. It's a pleasure to present and share with you today my presentation titled Optimizing Demand Forecasting in Supply Chain Through Machine Learning, Practical Implication for Businesses. First of all, let me start with the background of the problem and the motivation of the research. As you know, the demand forecasting play a critical role in supply chain decisions, which starts from the inventory planning all the way to the logistics and the customer service. When forecasts are inaccurate, companies simply experience either an overstocking, which is increase the cost, or actually stocks, which is harm the customer satisfaction. Mainly, the traditional forecasting method assume the stability and in linearity, but today's supply chain actually facing a lot of global disruptions, rapid technological change, which is actually as a gap motivate the need for more advanced and adaptable forecasting techniques. So having this in mind, the literature shows traditional methods such as the ARIMA and expositional smoothing perform well actually under a stable condition. But when we are talking about let's say nonlinear or irregular patterns, this method is actually showing what we call it a struggle. However, on the other hand, the machine learning models, including random forecasting, including boosting and LSTEM, provide more stronger capabilities. So they can both capture the complex relationship and integrate into a wide range of variables. And the recent study honestly show a clear improvement in accuracy when the machine learning model are used alongside or instead of a classical method. So in this case, the gap itself highlight these points, which most of the study focus mainly on algorithmic accuracy without discussing how improved forecasting actually impacts the business performance. So we can say that there's a limited work connecting both machine learning based forecasting to the inventory saving, revenue improvement, and operational flexibility, where this study actually contribute by comparing machine learning models with the traditional models and also demonstrating how better forecasting produce a measurable business value. Okay, so this study mainly aimed to evaluate the performance of the key machine learning models by comparing them with the statistical benchmarks and integrate these insights into a business intelligence system. So ultimately, the goal was actually to highlight the practical implication for inventory management, cost optimization, and supply chain responsiveness, especially within the UAE context. Okay, so the data set used in this study integrate the multiple table, including orders, customers, payment, and product, which carried out to the what we call it extensive data cleaning. And such a stage of data cleaning actually is really important for us to handle the missing values, dedicated outline using statistical methods such as z-scores. So all these, let's say, cleaning methods and quality steps came to ensure the constant and high quality data set before the model get trained. Okay, so we engineered several features such as historical trends, customer frequency, and price elasticity Definitely, we are focusing more to the exploratory data analysis, the EDA, as a tool to include the histogram, heat map, and correlation matrix, which has helped actually relieve the patterns in demand behavior. So these steps actually refine the data set and strengthen the predictive power of the model. So we tested a range of models, linear regression and the REMA served as to be served as a baseline, while on the other hand, the machine learning models such as decision tree, random forest, XGBoost, and the LSTEM represented the advanced approaches. So each of the model offer an advantages, but we talking in particular about the random forest and the XGBoost, where we see or notice practically strong for a tabular business data. Okay, so we used a training and testing split along to the keyfold cross validation to ensure the model stability. So the hyper parameters were tuned using grid search, while the performance was measured using the evaluation matrix such as the mean absolute error, the root mean square errors, and the mean absolute percentage error. All of that help us to identify the model with the best generalization capabilities. The decision tree model in particular show a high error rate and overfitting. In contrast, we can see through the visual, the random forest model achieve an excellent accuracy with a very low error matrix. So as you can see to the right, both visuals actually compromise and confirm the reliability and the prediction closely match to the actual value, where we can see the comparison between both of the models being or approach being used. And again, this is just an example of the approach that we followed in the study. In terms of the business application and improved forecast actually reduce the overstocking and the stocks, as we know, and of course improve both cost efficiency and the customer satisfaction. So this is a general idea. However, we actually we have to include throughout this paper that's also strengthen the supply chain coordination and enhance operational agility, in particular during the demand fluctuating and seasonal events. Forecasts were integrated into the BI dashboard, and such a dashboard actually been important for us in this study to support the decision making throughout the real-time visualization and alerts. So we also used the shape to explain how each variables influence the prediction, increasing managerial trust as well. In UAE in particular, sectors such as the fast-moving consumer goods, retails, and manufacturing sectors are greatly benefit from the machine learning based forecasting. So this approach supports the national goals as well as it's related to the efficiency, sustainability, and digital transformation. We would like to add also that this study limited by a reliance on the historical data and conceptual complexity in a large data set. However, a future work can incorporate a real-time data, advanced deeper learning architecture, and applications in a wider industry. To conclude, machine learning, particularly random forest, substantially enhance the forecasting accuracy and generate a meaningful business value. That happen actually by integrating machine learning and BI and explainable AI, which is organized as an organization, can build more reliant, efficient and future-ready supply chain. And this is the end of my presentation. Thank you for your listening.